All right, in part C, we're told that the derivative of ln of 1 plus x squared is 2x over 1 plus x squared. And that means that since we're working with, we already have 2x over 1 plus x squared, that means we can go backwards. Its integral is ln of 1 plus x squared. And so we want to find the first four non-zero terms of the Taylor series for ln of 1 plus x squared. So we're just going to take the integral of each of the terms in 2x over 1 plus x squared. So we start. We have 2x. That's going to become 2x squared over 2, which is x squared. Then the next term is negative 2x to the third, and that's going to become negative 2x to the fourth over 4. So that's going to become negative x to the fourth over 2. The next term is positive 2x to the fifth. That's going to become 2x to the fifth over 6. So that's really 2 over 6 is 1/3. It's going to become x to the sixth over 3, and that's positive. And finally, negative 2x to the seventh is going to become negative 2x to the 8 over 8, and 2 over 8 is 1/4. So it's negative x to the 8 over 4. And those are the first four terms. Now it doesn't ask for the general term, but if you were going to do the general term, the negative 1 to the n is still a constant, 2 is still a constant. Then we're going to increase the exponent of x from 2n plus 1 to 2 times 2n plus 2. We're just increasing that by 1. And then we're going to divide by the new exponent. However, since the denominator is 2n plus 2, you could factor out a 2 from that, and that 2 would cancel with the 2 in the numerator. So we factor out the 2, we get 2 times quantity n plus 1, and then those two 2's cancel. And we're simply left with negative 1 to the n times x to the 2n plus 2 over n plus 1. So then our general term is going to be negative 1 to the nth times x to the 2n plus 2 over n plus 1. And you can see that if we start from the zero term, first, second, third, etc., the exponent of the first term, 2 times 0 would be 0 plus 2 would be 2. 2 times 1 would be 2 plus 2 would be 4. 2 times 2 would be 4 plus 2 is 6, etc. So the exponents work. Then in the denominator, 0 plus 1 is 1, 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 1 is 4. And so that's how our general term works out. Now there is another way of having done this, although this was pretty easy. Another way of doing this is to recognize that the natural log of 1 plus x squared is also a transformation of one of our big 7 functions. And I'm going to scroll up the screen here. And I'll take a minute to talk about that, since that is also very important. Now that it comes from the function ln 1 plus x. Now I think that that is probably the most difficult function to derive using the long way. But the ln of 1 plus x is sort of a cousin to the e to the x. And I'll talk about how I remember the ln of 1 plus x when I can do the e plus x, which is one of the easiest ones. So e to the x is just 1 plus x squared over 2 factorial plus x to the third over 3 factorial, etc. So it's just x to the n over n factorial. Now with ln of 1 plus x, it doesn't start at 1, because ln of 1 plus 0, or f of 0, would be ln of 1, which is 0. Aside from that, it looks like the e to the x, with two small distinctions. First of all, it alternates, and second of all, there are no factorials in the denominator. So the next term would be negative x squared over 2, not over 2 factorial. Then x to the third over 3, positive, minus x to the fourth over 4. So if you can remember e to the x, then you can remember ln of 1 plus x. Now what we want is ln of 1 plus x squared. So we're simply going to replace every x with x squared. And so you can see that that gives you exactly what we had above, and it would give you the same general term as well. Now, so the point here is that there are different ways of going about this. The more ways you know, the better chance you have of getting it correct.